So I've once again got this UEI Model 301 oscilloscope on the bench. And last time we took a play in it, I had thrown a couple of electrolytics in here short term. We actually watched when these electrolytics fail and boil out. And I've thrown these two guys in short term. We've got heat sink compound all over the end of the pointer here. Get that wiped off. We'd replace two of these electrolytics just to get the thing up and running. I want to replace these two with a more appropriate cap. We've got two 8 microfarad electrolytics in this orange guy here we need to replace. We've got this 10 microfarad 450 volt guy up under here that I need to figure out what I'm going to do with. If I recall correctly, the working voltage across this cap was nearly 600 volts. Which means I'm just not going to throw a 450 microfarad cap in there. I think what we're going to end up with is an 8 microfarad 900 volt configuration, because I have the parts to do that in here, which I should be close enough to the 10. Anyhow, I'm going to plug this guy in. Actually, I'm going to power him up, and I'm going to go ahead and look at those working voltages again. Currently I have the inputs disabled here. They're disconnected. I'm going to replace these jacks on the front at some point. I just haven't gotten to it. So anyhow, let's put power on and hope no smoke or fire comes out. And so far, no. We see heaters in the tubes. That's a good sign. I see the heater and the CRT coming up. We have a trace. That's a good sign. Nice, pretty stable trace. So let's get in here and look at these working voltages again. Chassis on this is ground for everything, it looks like. The negative side of these caps ties back to ground through this wire right here. So we've got a working voltage across this guy. That doesn't make any sense. Is that not going? That's going back to ground. Lost connection. There's 450, it's all over the place, but there's 450 volts there, which is right at the rating of the capacitor. 463 there. Again, these are high. They're higher than I'd like them to be. 254 volts on the one cap here. The other one snakes around to here. I've got just under 200 volts there. And this is the guy here where I believe the 600 volts was found. Again, his negative lead is going over here to the stud to the chassis. And if we follow his positive lead, this will connect to it right here. And at the moment I'm only seeing 130 volts there, which surprises me. I thought I was seeing the nearly 600 volts here. Did I trace that out wrong before? That's possible. No, that positive lead definitely comes around to here, and that's only at 130 volts. So my memory is wrong. I swear before I saw 600 volts here, but I guess not. I guess I can get in there actually directly on the... Yeah, there's only 130 volts there. The scope is operational. It's interesting that centering. I see why. If we bring the vertical horizontal back down to a trace that fits the screen, not driving it so hard. So really, what I'm now seeing, and I'm glad I retested this, is I should be able to do a direct replacement of him with the caps I bought, both of these. A direct replacement of this guy down here, which is, well, both of these are, there's 462 volts. and 453. The caps I bought, let me unplug this. Let those caps bleed down. So the replacement caps I bought are in the box here. I picked these up on eBay a few days ago, and they've been delivered. So we'll go ahead and get it open here and take a look at what I bought. This was from somebody on eBay who what do you call himself? Tube Audio Supply LLC out of Jacksonville, Florida. He seemed to have all kinds of interesting replacement parts, etc. I'll give him a shameless plug here. Why not? There's this card. I'm not endorsing this person. I know nothing truly about them beyond they had some very inexpensive 450 volt 8 microfarad electrolytic caps. And when seeing IC, so these do match the picture. IC to me is Illinois capacitor, which in my mind is a quality brand. So these should be good caps. So I'd really like to have a higher working voltage down here, capacitance. I'm going to go ahead and replace this 10 microfarad up here with one of these 8s. Although I'm still kind of mystified why I saw 600 volts there earlier. I'm dropping stuff, obviously. Actually looking for another bag of capacitors. But I don't know what I did with it. Because I may have something closer to 10 that I think were axial lead that would probably make a better replacement there. I just looked at that bag of caps a few minutes ago, which is why it's now completely lost. Ah, the wonders of a muddled mind and a messy bench. There they are. So these are 10 microfarad, 400 volt. This actually will make a more suitable replacement. So these are Nishikon. So these are real high quality capacitors, Nishikon. 10 microfarad, 400 volt. Plug it in, let it come back up for a minute. So if that working voltage is truly 130 volts or so, this will make an excellent replacement up here. If I recall, both of these were operating at about well under 200 volts, as I recall. Just double check one more time. 140 volts. This is a 400 volt rated capacitor. That'll make an excellent replacement for this guy right here. It's perfect. These were under 200 volts. Well, no, okay, 240. Memory's not as good as it should be. That one actually comes around to here. And I didn't get good contact. Still not getting good contact. That lead does come around to, there we got it, 187. So these two 8 microfarads, these caps I got on eBay are 450 volt 8 microfarad. These should make, two of these should make a perfect replacement for this guy. And there's 2 caps inside of that one package. And then we get down to these 2 guys where the voltages are actually high. So 460 volts and 452 volts. And because these are rated 450 volts, I really don't want to just drop that in there because it's right at the rating of the cap. One way to do this, and I'll kind of hold them here and do this, would be to take 2 caps in parallel with the leads hooked together. And by doing that, what that'll give me is 16 microfarads at 450 volts, because you add the capacitances together since they are in parallel. If I then made 2 of these, I'll actually twist the leads here slightly together so you can see what I'm talking about. So you turn it around here and hopefully you can read the labels. So I've got 2 450 volt 8 microfarad caps here in parallel. Parallel meaning the leads are hooked together on both ends. Because they're in parallel in capacitors, you add the capacitance. So we've got 16 microfarads here at 450 volts. If I take two more of these, and I do the same thing, we've again got two capacitors, both 8 microfarad, 450 volts. So we've got 16 microfarads because we're in parallel. We add the capacitances at a working voltage of 450 volts. If I then take this parallel set and this parallel set and I join them together, because they're in series, the capacitance halves. So 16 and 16 divided by 2 means there's 8 microfarads total capacitance there. And because they're in series, you add the voltages. So 450 plus 450 gives me 900 working volts across these caps and gets me back to the 8 microfarads I need. Again, these two together become 16. These two together become 16. Because they're capacitors in series, you end up with half the capacitance. You basically take the total capacitance, add it together, and divide it by 2. So this would give me 16 plus... well, I said that very poorly. Anyhow, this ends up at 8 microfarads. This is 16 and 16. You divide by 2 in this case, and you get down to 8 microfarads. But you add the voltages to get 900 working volts. I have enough of these here to build up 2 full sets of these. And it would just be a matter of finding room in here to build these up and put them in there. And of course, I wouldn't leave them, wired this far apart. I would make a much tidier package out of these and then find room in there to put 2 of these. And this will give me plenty of gap between the working voltage, the actual voltage, and the working voltage for these caps down here that you've got, this very high voltage on them. Again, 460 volts and 452. These caps that are in here, I think, are rated 400 volt or 450. They're really not appropriate. I'm stressing them here. And they're also axial lead. The leads come out both ends. And this is really done point-to-point construction, which almost always means you're looking at radial lead. This style just works better in point-to-point wiring. So the next step for me is going to be removing, let me unplug him again before I forget, is going to be removing this guy, getting that 10 microfarad one into circuit there. I'm just kind of looking at physically how I'm going to do this and get him replaced, and that's what I'm going to tackle first. So the next thing I'm going to do here while we're sitting here is I'm going to take a jumper lead and I'm going to get onto the chassis, or chassis, however you want to pronounce it, and I'm going to discharge all these caps. So I'm going to go to the positive side and I'm going to fully discharge all these caps before I start mucking in here. A capacitor can hold residual charge, a good cap, for a long time. The circuit here will bleed charge off, but I want to make absolutely sure that these caps are discharged. And now I'm looking at this one again, wondering, did I measure the right pin? Well, we're going to power it back up one more time. So I swear I found 600 volts up there before. And the fact that I'm only finding, it's dancing around 170, 200, 166, 157. It's rolling off very quickly. Is another sign this cap here is potentially becoming very leaky and failing when the voltage is dropping and dropping. I'm going to switch it off. And I'm actually going to clip the voltmeter in here. Again, I'm going to discharge him so I don't bite myself. There's still 8 volts left, no big deal. And I'm going to turn the power back on and see what it surges up to. 170, 190, 200, 205, 207, 208. Bring the intensity up. As I bring the intensity up, that voltage starts to roll off very quickly. 150, 140. I'm guessing that cap is leaky. I'm going to bring the power off. I'm actually going to switch to volts AC and see what kind of AC component I may have across that capacitor, if anything. Yeah, it's just noise. Ooh, 52 volts AC, 55, 24. I think that cap's become very leaky and it's not filtering the value it's supposed to, or perhaps there's some kind of an AC signal through it. I don't know. The fact that I see a solid DC value on it, even if it's drifting around, I see it drifting, not jumping randomly up and down, says to me it probably is meant to have a DC voltage on it. And watch it roll off here. I'm just guessing the cap is old and leaky. Voltage is at 30, 20, 17, and rolling off. So I will turn on the soldering pencil. I will futz around in here for a second and make sure all of these caps are discharged. When I get him, that red lead comes up over here. And I am rubbing intensely just to get through any oxide here, just to make absolutely sure I get it discharged. Those caps should be safely discharged. That doesn't mean that I don't unplug it. It's unplugged as well. You do everything you can to protect yourself. So the problem now becomes getting him out of circuit. Don't know that this tip is going to be sufficient to actually heat that. The JBC does have excellent thermal characteristics. It might actually be able to, let me add some solder here before I destroy the tip, and the solder on the tip will actually give me much better heat conduction through to, of course I don't want to burn myself. The wonders of a JBC tool, that's actually a ground connection there back to the chassis, and that just heated that right up and released. And it looks like, honestly, I don't know if the leads are wrapped in here or not. Whether I can walk him loose. No, I think the lead is. So what I'm going to do here is I'm just going to go ahead. I know I'm going to throw this cap away. I'm going to just snip the lead off the cap. It's an old 10 microfarad, 450 volt. You can tell by the positive over here it's a polarized cap. It's an electrolytic. It's probably as old as I am, which is pretty damn old. Anyhow, he's going away. I want to think about how to do this in a safe manner. I'd really like to work that lead out of there. And I don't know that I'm going to be able to. I think I'm going to go ahead and try to pull this resistor out. There's a couple of ways to do this. Let me get a little pair of needle nose and we'll try to free the lead on this resistor. And I do have, of course, the manual that goes with this. It did actually move a lot. So if needed, I'm violating the rules here by attempting to bend a lead with the tip of the soldering pencil. That's really stupid. But I did manage to walk that resistor out. Mr. Carlson just did a video on don't do what I just did. And that was on using your soldering pencil tip as a pry bar. It will take the coating on the tip and rub it off down to the bare copper underneath, and the tip will fail much faster. He's actually got a good tutorial video up there. So this wire is actually loose now, so I can get in there and just trim the dead solder off the end of the lead, and I should be able to just pull that wire right out of there. and we fished it out. And what I'm going to do is pull the insulation off. It was originally on the wire. I'm going to use that insulation, I think, on the new cap to guard the lead coming into that tie point, because I'm going to bring it in from the top rather than try to work it underneath like it was. And I'll bring that resistor and this capacitor back to that lug there on the tube, and then I'll bring the ground back up here and be able to successfully replace that. So let's see if I can just clean some of the solder off there. That lead's already got a decent J hook on it. I'm going to get in here close. I'm going to bend myself a little hook that hopefully will allow me to get him to hook in there pretty simply. And it has. If I can get the resistor to catch in there as well in the same hole. And there's the resistor. In Mr. Carlson's lab, he talked about not needing to bend the leads over for mechanical contact, and in low vibration environments, I think he's right. I still went ahead and bent the leads over just to hold things in place. I wish I'd have put this cap lead underneath. It would have made this easier underneath. Before I've soldered, I have plenty of length to get the negative lead up in place here. I'm going to take the leads that I bend over and I'm going to pull them down straight line to reduce the potential of shorting to either side. He's well insulated. He's back where he originally was. Again, relying on just being hung there in the air. We'll go ahead and resolder here. Oops. I'd like that to flow a little better in there. There. I think that got it. Yeah, those feel nice and solid. I'm just going to bring him right back up through the same hole the other one came through. Need about that much lead to do it. And all I'm going to do here is grab the lead, get down underneath into the eyelet, hopefully. See about melting the solder and pushing him up through there. There it is. Get a good flow. Let the solder cool off before I release so I didn't take any mechanical stress. We've got the positive side. It's got the ring around it here. The little indent is the positive side. Negative side of the cap is back to the chassis here. And we're back together. I'm going to power back up now at this point and just make sure it comes back to life. Get the solder out of the way here and measure the voltage across that cap and see if it's now more stable. So, and the capacitor didn't explode when I applied power, so. There's the trace starting to come up. Trace to me actually seems a little more solid here. It's not dancing up and down. There was a lot of noise in the trace before. It was just kind of doing a slow dance. This needs some focus work, but oh, there it starts to go. It's dancing a little bit again. I'm curious to get back in here now. Look across that new cap and see what kind of voltage we've got. Got ground back to the chassis. I've got 130 volts, 129.4 actually, and it's nice and stable. It's not doing that weird where it was moving up and coming down and moving up and coming down. So I'd say we're safe. 450 volt cap. It's being operated well within tolerance at 130 volts. The trace is there as it was before, so we haven't damaged anything. Now I'm going to move on to this guy. And at this point I really want to pull this ring out of here if I can. Don't know if I can get it loose or not. I'm going to need the room in there. Problem is that the nut for this is well hidden up under there. It's going to be hard to get out. I can feel the nut turning. Now, in this case, I'm just going to clip the leads here completely. Did you catch what I just did? It is unplugged, but I have not discharged the caps, and I don't want a little shock here. Again, think before you do. I just want to make absolutely sure. I don't need any nasty surprises. And now I'll go ahead and just clip him out of there. I will most likely reuse those leads. I don't know if I can get him to slide out of the band. I don't really want to cut this band to get it out of there, but I may have to. I don't know if I can get in there and get on that nut with a pair of pliers. It's a very inaccessible place. At this point I may just cut the band off. Find a better pair of cutters for doing this. If I can cut it. Nope, I'm not going to be able to cut that. That's pretty damn tight. Get in there and get on that nut and maintain pressure on it. Looking across my sea of pliers here, see if there might be something that'll work for this. Okay, that's got a good bite on the nut. Yeah, it broke loose. Excellent. Ooh. Knocked the soldering pencil out of the holder, and it dropped onto a baggie, and it's making all kinds of stinky, burning plastic smell. That's not good. We wet the tip, get it back in the station, and it'll go back into idle mode here. So another thing I really like about the JVC is the tip goes into sleep mode really quick. So again, this is 8 microfarad. It's a dual cap, two 8 microfarad, 450 volt caps. You have the two positive leads and the common negative. I will hold on to these at this point. They may prove useful at some other time. Getting this one to release off here might be interesting. Another cap for the trash heap. Now we want to go ahead and swap in two caps. And I'm debating how to do this. I'm probably just going to reuse these leads and just hang these in here on the leads. This one runs all the way over here, so it's going to require the wire. This one doesn't necessarily require the jumper wire, but it'll make it easier to do if I just... Oh, well, I managed to cut the wire itself. That was pretty stupid. Can I do what I'm attempting to do here? I didn't realize this was not a solid wire. I probably can't get the insulation back on there. I could use a piece of shrink tubing to do this. I'm sure many people are screaming out there, "What the hell are you doing, fool?" Didn't get it cut sufficiently to walk off on its own. Wow, that is tough insulation. There it is. Not that that was very gentle, but so we're on this guy and this guy, and I think I'm just going to go ahead and pull that lead out and just directly, I think that's what I'm going to do for that one. See if I can get this wire to, for now, sit up out of the way. So I'm going to go ahead and pull remains of this lead out of here, and we'll just anchor the capacitor directly in there, being that this is a stranded wire. Once I get the solder on the lug to melt, I should be able to do exactly that and just pull it out of there. Let me look at this for length. I'm going to want to take 2 of these. I'm going to want to bring the leads together. To get the common ground on them both. And then we'll use that pigtail to come to here. Give him a little more length so he's centered there. And the other one will get tied here. And I'm just kind of feeling for position. I do need to strip some insulation here and hopefully not cut the wire off accidentally like I did a minute ago, though it wouldn't be the end of the world. That'll give me plenty there to get a good ground connection to these. I want it at about that length. I'm going to take a little bit off here. Again, I am paying attention to clarity of the caps as I'm doing this. Get this to flow here. And hopefully push that lead through the eyelet. Can't get in there. Keep losing my grip on the cap. Nope. Lots of other leads in that. I cannot hold on to that. That's irritating. Okay, be that way. Let's remove some of the solder from this. Get a better look at what we've got. Yeah, it's got multiple leads through the hole. Can I get the solder that's got that wire caught to cut? Sort of bend that lead a little squarer. Don't know if I'm going to have enough room there or not, but I'll try. Get some fresh solder on here. See if I can get that to flow again. There it is. So I did manage to work that lead through. There. Oh, it's still hot. I'm going to go ahead and spin these around. And I'm just going to make a short pigtail here. I'm sure there's 1,000 better ways to do this. But again, this is not going to be a daily use scope. Couple windings around there. And not having a whole lot of success, as you can see. Not the best connection I've ever made, but it will work. Still smell the melted plastic from earlier. Get a nice flow there. These guys are going to sit back in here. And this ground's going to come into about here. Same issue here that I had over there with getting these somewhat mechanically joined. I think in this case I'm going to twist these a bit more. I'm going to make my own little eyelet. Feed that wire up through that little eyelet. I'm going to fold it back, crimp these. This is the negative side here, so it's safe. Mechanically, that's not the prettiest thing I've ever done. Let's go ahead and get it to flow. Got a nice flow. Plenty of solder. I'm not happy that cap is floating as much as it is. If this was to get dropped, I don't think it can move enough to touch the bottom of the actual chassis when it's on. You know, that is what it is. Mechanically, it's certainly not pretty. Let's look for blue smoke. Again, the bands and the plus sides are to the red leads in this case, and the blacks come back to the chassis, so I know the polarity's right. We'll bring the power up again. Oh, there's the trace starting to come to life. do have the vertical input floating. I'm curious here, if I grounded the vertical input, would it stop some of that noise? Nope. Still wandering around a bit, but that's okay. Well, we haven't broke it. Actually, I was going to measure the voltage across those. Let me bring it back up. So on him, we've got 185 volts. 234. They're both 450 volt rated caps, so we've got plenty of overhead. We won't be stressing them at all. Now we tackle this mess. Let me actually discharge here first. We are unplugged. See about pulling these out of here. So these are 10 microfarad rated 450 volts that have been ran. What did we measure on these? It was over 450. I don't remember how high it was. That we want to replace here. And I just realized that I don't know where the one of these went to. I'm going to have to look in the manual to remember where that lead came from. Manuals and photos are your friend. Let's find some pictures. That picture doesn't show me enough detail. There's actually a line drawing in here that will cover these a little bit better. So orientation of this is this way. And these went to the second tab down, and the other one went to the second one up, so where I thought it went. So they're with one in between. So one of them went between these two diodes. Well, we can't see here. One came in here between these two diodes, and the other one is here. So now it's a matter of deciding what I'm going to do here. I'm actually going to build up a sea of caps, which would take up significant room. Is to pair these up into. I've not been able to find caps higher than a 450 volt rating. That's been part of this. Is kind of a mess. Not really kind of, it is a mess. I'm debating here how to approach this. So I have to get, this is a lot of capacitors to fit in there. It would be be a lot, and I don't have enough to do it. So my plan before doesn't really give me enough capacitors. I would need 8, and because I bought 10, you know what, I put the wrong cap in up here. It was supposed to be the 10 microfarad, and I put in an 8 there, and I'm not going to undo that at this point. I think we are just going to use 2, and we're going to run them hot, knowing that it's going to kill life on them. That there may be a spectacular failure at some point. Best laid plans of men and mice. You may have heard Rosie there. She was ready for her dinner an hour ago. Yes, I know you're hungry. It is getting dinner time. Got one that we're going to bring in here. Again, if I was going to run this scope heavy, use it a lot, I would be more worried about this. So one of them went to the second tab down where I'm at, just as I've done there. And the other one will go lead's got a little crimp in it from me bending earlier. It's a little short, but it'll work. The second one's going to be in here. Hopefully I can get the solder to flow and get that lead through there. There's a couple of very old silicon diodes sitting here that I should probably be protecting with a heat sink. I didn't. I probably should have. On old semiconductors and transistors, etc., they make a little aluminum heat sink. You can use an alligator clip, something that you clip on the lead that becomes a heat sink to keep the heat from getting up into the device itself. Those were old enough that probably would have been a good idea. Obviously, based on what you just saw, I didn't do that. Pigtail there. Get this lead mechanically wrapped around here off the ground point. Trim away the extra. Well, it's certainly not pretty. That has replaced those electrolytics. Again, the positive is to the terminal strip. Ground comes back to the ground tie point back here. I have every expectation this is going to power up and work. Although potentially those caps could become unhappy really quick and ruin my day. Hopefully they won't explode. It's interesting, the trace is size. It's interesting that the issue used to be that the nonlinearity was to the left, and now it's shifted to the right, which is entertaining. If I bring the intensity down and muck with the focus, I can actually get a pretty clean line there. It's not great, but for what it is, you know, you're not going to see superb detail on it, but let's do some DC voltage measurements. 461 on a 450 volt cap. 452 on a 450 volt cap. You know, these are, of course, you know, 450 volt cap obviously is manufactured with some tolerance more than that. 470 or 500 volts, whatever that manufacturing tolerance is, shouldn't be relying on that tolerance. I'm really making a stupid mistake here in a lot of ways. Again, this scope is going to become a simple curve tracer. I'm going to use the circuit from Mr. Carlson's lab up on his Patreon site, and I'm going to turn this into just a simple curve tracer. So it won't be huge amounts of operation. It'll be on, poke at some components, off kind of thing. I'll be able to keep the look, although I am going to replace, like I said, these jacks. Just because the ground ones broke off. I want to replace these with, haven't decided, BNCs or banana plugs. It'll make it a little easier to use. Of course, they may not even actually be connected externally. It'll kind of look different from the original, but I don't see that mattering. Yeah, these voltages continue to be right at the high limit of those caps. 230, 180, 126. Anyhow, at this point, we have replaced, where's my little plastic pointer? I know it's got it. We've replaced 5 electrolytics. We've replaced these poly caps. We replaced this guy. I would have rather had a radial lead, but that's all I could find. He was replaced. These were replaced. So the electrolytics were replaced. I really think that's all we had to tackle. It's taken, I think, 3 videos now to get through this for not a lot of components. As I've said before, this was definitely a kit build, not a particularly well done one, though that in itself kind of adds charm. The interesting little kit. I'm going to, while we're playing here, if I can find the lead I need. We'll actually do a bit of playing and drop some signals in. Get my function generator powered up. Need to get on which one's channel 1. The bottom guy's channel 1. We did this before, but it'll be a fun play again. Get on ground. Get on the input. That cap is, of course, capacitively coupled. Click on the output. We should have a 1 kilohertz sine wave at 5 volts amplitude, which is certainly not what we're seeing. Let me get the sync. If I can grab sync on that. I'm really not able to get sync on it. There we go. Somewhat. Of course, that's really just me matching the sweep rate pretty close to the signal. It's pretty difficult to do. External sync, internal sync. I'll kick this up frequency to 100 kilohertz. Expect that to swamp it. Bring our, see, we've got a 5 kilohertz to 100 kilohertz range here. That should be 100 kilohertz input. We are on the 500 to 5K hertz range. I would not have expected that to sync up, but it actually is grab and sync. Oh, I just got the sweep. Would have expected to need to be up here at that's a rather interesting. I can hear the electronic singing. You probably can't in the scope. When I get the, it's actually singing as it's trying to sync right there. It's pretty cool. It's 100 kilohertz. That's the top end of this is 100 kilohertz. Let's go down something really low. Let's go 60 hertz. Go back all the way to the bottom end. See if we can grab a sync. As a kid, I would have loved playing with this. You're obviously not going to make high precision measurements with it. 100 hertz. I can get a somewhat stable display there. Let's change the waveform type to square wave. Go back to 100 kilohertz. And no surprise, this looks like a triangle wave on here, even though it is a square wave. You can hear it squealing again, very unhappily. It should be a square wave, and the amount of capacitance and everything coming in is, I'm sure, mucking with the signal. We'll change it to a ramp. Pulse train. Just random noise. Wow, it suddenly looks like a curve tracer. I'll go back to sine wave. That's what this thing was really designed to display, was simple sine waves. Anyhow, this is yet another video in the UEI Model 301 oscilloscope muck around. With me doing a pretty lousy recapping job. It is what it is. I'm certainly not saying do as I did. Lots of great tutorials out there. People with tons more experience in this analog stuff than I have. I don't think it looks horrible. Don't think it looks great. I'm running these hot. Shouldn't be. Anyhow, this is what it is. We'll come back next time and take a look at replacing these jacks. and then begin looking at the articles or the videos up on Mr. Carlson's lab as I build out the curve tracer circuit. So anyhow, till next time, talk soon.